Okay, so have you ever had that moment, when your favorite app gets an update and suddenly it's like everything's just gone haywire,
Mhm.
features break, it's slow, you just want that old version back?
It's like they tried to, I don't know, add a sunroom to your house, but in the process, they somehow managed to cut off the water supply to the kitchen.
Exactly. And, a lot of those software headaches, they can be traced back to how the code itself is organized, or I guess disorganized is a better word. That's where this idea of separation of concerns comes into play. So, C for short. It's a bit like having a well thought out blueprint for your code, right?
Yeah, it's all about breaking down a software system into these distinct sections, each one handling a specific, concern or job. So instead of one massive tangled web of code, you've got these neat little compartments for each function.
So, are we talking about like separating the code that makes the app look pretty from the code that actually processes your requests?
Precisely. For instance, let's say, think about a social media app one you might use. Your profile picture, your friends list, even the action of you posting an update in good software development. Those would all be managed within their own dedicated section of the code.
That makes a lot of sense. So it's kind of like, what's it called? Modular furniture, right? You
Right.
can rearrange the pieces, upgrade sections without bringing the whole thing crashing down.
And just like with that furniture analogy, well-separated code, it tends to be more robust. It's easier to update without creating those annoying ripple effects that cascade into, bugs and crashes.
Which is a definite win for us users. Our source uses this analogy of Legos to describe this idea of modularity. Each little Lego brick is self-contained, but you can combine them in tons of ways to build something amazing, right?
And the beauty is, if you decide you want to change something,
Yeah.
you don't have to demolish the entire Lego structure, right? You just swap out or modify the module that needs to work. It's the same principle with well-structured code.
Yeah. So modularity is about creating those independent chunks of code. But the source also keeps mentioning encapsulation. Is that another piece of this puzzle?
Absolutely. Think of it this way. You know how you can change the settings on your phone, like adjusting the brightness or notification sounds, without needing to understand how the phone's operating system actually makes those things happen? That's encapsulation in action.
So it's like each module is this little black box just doing its thing behind the scenes. You don't need to be a coding whiz to use it. You just need to know what it does and how to interact with it.
Exactly. Encapsulation simplifies things for developers because they can work on different modules, without stepping on each other's toes.
And I'm guessing that also helps reduce errors, right? If one part of the code needs an overhaul, you don't have to risk messing with the rest of it. So we've talked about these concepts of like modularity and encapsulation, but I'm curious how this all actually plays out in, the real world of coding. Do different programming styles kind of approach SoC in different ways?
That's a great question. And, it's not a one-size-fits-all situation. Our source actually mentions that different programming paradigms kind of embrace SoC in their own unique ways. Let's take, for example, object-oriented programming, or OOP for short. It's a pretty widely used approach, and for good reason.
Right. OOP. I've definitely heard that one thrown around. Isn't that the one where you're like creating these blueprints for different parts of the software?
Exactly. So in OOP, those blueprints are called classes. Each class defines the properties and behaviors of, a specific type of object in your software. Think about something like, I don't know, your music streaming app. You've got your music player controls, your personalized playlists, recommendations for new artists. In OOP, each of those could be handled by its own separate class.
Okay, so it's like each class is responsible for a specific, like a zone of the app's functionality. And if a change needs to happen in one zone, it doesn't necessarily mean, ripping up the entire app's code base.
You've got it. It's like that modular furniture analogy again. Want to swap out the cushions on your sofa? No need to dismantle the entire living room. Now, our source also touches on another approach, functional programming. And that takes a slightly different perspective on how to achieve separation of concerns.
So how does functional programming tackle things differently? Does it still involve these like separate modules or classes?
It does, but the emphasis here is on creating what are called pure functions. Think of them like those cool single-purpose kitchen gadgets. You got your apple peeler, your avocado slicer, each doing one thing really well. In functional programming, these pure functions always produce the same output for the same input, with no hidden
So
surprises.
it's like a predictable recipe. You put in the same ingredients, you get the same cake every time. No unexpected ingredient substitutions or exploding ovens.
That's a perfect way to put it. This predictability makes, functional programs a lot easier to test and troubleshoot. And because each function is self-contained, the risk of those pesky ripple effects we talked about is significantly reduced.
So whether it's like the structured world of OOP or the streamlined approach of functional programming, SOS is all about bringing, order and clarity to the code, which in the end benefits both the developers and us, the users.
Absolutely. The key takeaway here is that SOS isn't about, rigidly sticking to a single programming style. It's a principle that can be applied effectively across different paradigms, each with its own strengths and weaknesses.
It's about choosing the right tool for the job, so to speak, but always with that end goal of creating software that's, robust, maintainable, and can grow without turning into a tangled mess. And that's something I think we can all appreciate, even if we don't, speak a lick of code.
I completely agree. It's about creating a better user experience, which is what matters most in the end.
So we've explored all these different programming styles and everything, but let's bring it back to, us everyday users. How does this whole separation of concerns thing actually impact our experience with the apps and software we use every single day?
Well, okay, imagine this, right? You're super excited about the latest update to your go-to shopping app.
Oh, yeah?
They've promised all these cool new features and you can't wait to check them out. But then you open the app and bam, it's a disaster. Things are crashing, your saved payment info has vanished, and the whole experience is just frustrating.
Oh, tell me about it. We've all been there. It's like the app developers, they just threw a bunch of random code at the wall and just hope for the best.
Right. And while sometimes, sure, there are other factors at play, more often than not, this is where poor separation of concerns really kind of rears its ugly head.
Hmm.
When code is all tightly interwoven like that, changes in one area can have these totally unforeseen consequences elsewhere, and updates become risky. That's how you get those frustrating bugs and glitches.
So if an app is designed with, sauce in mind from the get-go, those updates are more likely to go smoothly. New features would just, seamlessly slot in without messing everything else up.
That's the idea. It's about creating those clear boundaries, clear interfaces between the different parts of the code. Think about it like this. When cities are designed with those well-defined zones, residential, commercial, industrial, it's much easier to manage growth and change without, disrupting the daily lives of the citizens.
That's a great analogy. Yeah, it's like you don't want to go building a factory right next to a school. Each area has its purpose and its own set of rules.
Exactly. And just like with a well-planned city, software designed with SoC in mind can grow and evolve gracefully. And that's crucial because as technology advances and user expectations change, apps need to adapt without becoming a tangled mess.
Our source mentioned this idea of scalability. Is that what we're talking about here? The ability of software to handle more users, more data, more features without, falling apart at the seams.
Precisely. Think about a social media app that suddenly, goes viral. If that underlying code isn't well structured, it's like trying to fit a growing elephant into a tiny car. Sooner or later, something's got to give.
So, in a nutshell, good SoC means a smoother, less buggy user experience. And it allows apps to, evolve and adapt over time without turning into a chaotic mess. It's kind of like I don't know, the unsung hero of the software world. We might not see it, but we sure notice when it's not there.
Absolutely. And the next time you're enjoying a seamless experience on your favorite app, spare a thought for those developers who've embraced separation of concerns. They might be working behind the scenes, but they're the ones ensuring that your digital life runs smoothly and efficiently.
So the next time I'm frustrated with, with a glitchy app, I'll be sure to channel my inner developer and whisper needs more so.
Right. But in all seriousness, the more we appreciate, as users, the importance of good software design principles like SoC, the more we can advocate for, just better digital experiences for everyone.
It's about understanding that there's a lot of thought and care that goes into building great software. And sometimes it's those things we don't see, like a solid foundation built on separation of concerns that make all the difference.
Well said. And as users, we can all do our part, by supporting developers who prioritize these principles and by demanding better from the technology we interact with every day.
It's about fostering a culture of, quality and user-centric design in this ever-evolving world of software. And who knows, maybe understanding a bit more about how things work under the hood can even inspire some of us to, try our hand at building the next big thing.
Now, that would be a true testament to the power of curiosity and a well-structured deep dive.
That's it for this deep dive. We'll catch you next time.